Now we will see the next point, that is the earth magnetism. Earth itself act as a huge magnet. So what is the basic behind that? What is the scientific theory it states? So actually there are various points. So why that earth will act as a magnet? So if you see the structure for that earth, definitely that the molten, that you can say the core, so definitely it is made up of your the material, so mainly which consist of your ferromagnetic material which are in the molten form. And we can state that again the earth is revolving at some constant speed, so which will constitute of your current, because the particles are revolving, and definitely because of which produces some current because of the movement of that electron. Basically we know that the electron is moving, so when the electron revolves around that your circular path, so that is a basic thing in the structure of atom. So let's say that in the structure of atom the electron is revolving, so which constitute of your a very small amount of magnetic field. So similarly this earth crust consists of different particles. So when this earth is revolving, so it consists of your revolution of this electron, and in short which consists of your magnetic field. So we know that the current carrying conductor is the source of your magnetic field. So this is the latest theory, you can say that. So where I can just say prove that so earth consists, or earth will act as a magnet because of its revolution. Again you can say that. So if you consider the moon, so moon doesn't act as a magnet because the speed, the revolution. Again if you consider the Jupiter planet, so the magnetism associated with it is greater because of its, you can say that, rate of revolution. So this is the earth magnetism, you can say that. Again the different theories, you can say that. So mainly one of the theories states that because of the ionization of particles from that cosmic rays around this your earth, and which will just revolve it, so which will produces your magnetic field. Now there are different terms related to this earth magnetism: the geographic meridian, magnetic meridian, angle of declination, angle of deep. So we know that whenever you suspend the magnet freely, it is going to show the geographical north. So I can say that at the geographical north, so definitely from this diagram I can say that from that geographical north, so this is going to show this freely suspended magnet geographical north. So that means there has to be the imaginary south pole. There has to be the imaginary south pole. So that's why that magnet is just directed towards the geographic north. So there is a imaginary south pole of that your earth is lying near to that geographical north. Again you can say that the another imaginary north pole is lying near that geographical south. Yeah, and that's why you can say that it is always that magnet is directed towards the geographical north. But now it is not exactly directed in the same way. So there is some angle. There is some angle between that your geographic axis and that of your magnetic axis. Yeah, obviously now I can say that. So that geographic axis, so we can say that. So definitely that is nothing but the north pole, and or you can say that north and south. This is the geographic north and geographic south. Again there has to be some line passing through it, so which is nothing but your geographic axis. Again if there is a plane which is cutting these 2 points equally, so this is nothing but your geographic meridian. So now this is nothing but your geographic meridian. Similarly we can consider that your magnetic meridian also. So that magnetic meridian is same. So we just said that if I consider this is nothing but earth, this is nothing but the geographic axis, this is nothing but the magnetic axis. The magnetic axis is not aligned with that your geographic axis. So this is, for example, geographic axis. This is nothing but the magnetic axis for that earth. Magnetic axis for that earth. And you can say that, so it is not going to just, you can say that, align in the same direction. There has to be some angle. There has to be some angle between them, and that angle is going to vary at different location on the earth. So this one you can say that angle we are just going to call it as a angle of declination. That angle of declination is the angle between this geographic axis and magnetic axis, that we will say that it will act as a angle of declination. So this is how we can just define the different terms. Again, similarly from this diagram, you can say that this is the magnetic equator, then that geographic equator. Yeah, so again you can see the position for that magnet which I have shown over here. So from which you will get the definition for that your geographic axis and your magnetic axis. So now this is your angle of declination that we have just seen. So this is one more diagram. So this is the geographic meridian and the magnetic meridian. Definitely you can say that the angle between them is theta. Yeah, so that we have just seen that is your angle of declination. So definitely that angle of declination is different at different places. So this is nothing but the angle of deep. So angle of deep is nothing but the angle through which this magnetic needle will get just move in this downward direction. So that is nothing but your angle of deep. This horizontal plane, that is nothing but the earth magnetic field of horizontal component. This one is the vertical component, and this is nothing but your angle of deep, the angle through which this needle get deep down when placed at a particular location. So you can say that. So definitely that is nothing but your angle of deep. So if you place this your needle at, suppose that you can say that on that first, if you put it on the equator, you will find that that angle of is 0, and when you put it on that your pole, either that north or that south one, so definitely that means I can say that the value will be 90 degree. It will turn completely through that 90 degree. So again you can say that the value of your angle of deep is different at different location. So for that definitely you should know the value for this BH component. Again I can say this is BH, and similarly another one I can show that this is nothing but the BV. Yeah, so let's say this is your BH. Again I can say that this is nothing but your BV, and this is your angle of deep, that is nothing but the del. So you can write it down in terms of del also, that is nothing but your tan del, which is nothing but your BV upon BH. Yeah, so this is nothing but the value of your that angle of deep, which you can write it down for it. So the same thing I have written over here also, this del, which is nothing but BV upon BH, and which is nothing but your angle of deep for this case.